at example number 3, which is dealing with joint variations. A joint variation combines inverse and direct variation. So we have an example which they can say, it is given that W varies directly, they even tell you directly, as the square of x, and it's a multiplication, and inversely or indirectly as inversely as y. Then they say number 1, write an expression for W in terms of x, y, and a constant k. So they want us to write an expression for W in terms of x, y, and a constant of proportionality. Then number 2, they are saying if x is equal to -6, y is equal to 12, and W is equal to 15, find k, the constant of proportionality. Then number 3, they are saying find the value of y, value of y when x is equal to 8 and W is equal to 20. So we have this. So we start. W, just the way it is, varies. You remember, varies directly as the square of x. So square of x. And it's a product, meaning multiplication. Inversely as y. Inversely means the inverse or as y. Then they say number 1, where they are saying write W in terms of x, y, and k. So the moment we say W varies indirect as x squared, this times that is x squared over y. So as usual, the 2 steps to be W is equal to, the moment you introduce an equal sign, also introduce the constant of proportionality. So therefore the expression for W will be the same as x squared, everything over y, x squared times k, it will be k. So this will be the expression, meaning our number 1 is solved, and the examiner or your teacher will be able to give you a thumbs up. The next stage we go to, this is an equation of variation, or the equation connecting whatever the joint variation we are having. So we go to number 2, where they are saying if x is equal to -6, y is equal to 12, and W is equal to 15. Anyway, this is not good practice when you're writing for the exam, but you can utilize this place so that we can contrast and compare. So if they say if x is equal to -this, so we write the equation. So number 2 will say W is equal to x squared k over y, which is equal to, so if x is equal to -6, so -6, which is x squared, and then our k, they say, or we are the one finding the k, so k we don't have it, the kappa, over, we have our y is 12, and then we have our W, which is 15. So from here we can say is equal to 15, and then we say -6 times -6 times k, everything over 12. If you want, you can cross multiply, but it's good when paper 1 you don't use calculator. So we know negative times negative, we know this would tend to be positive. So 6 here is 1, 6 there is 2, 2 here is 1, 2 there is 3. So 3 times k, it will be the same as 3k is equal to 15. divide here by 3 and there by 3. Therefore, our k, the constant of proportionality, will be equal to 5. This is our constant of proportionality, which is equal to 5. Now we go to the last part where they are saying if x is equal to negative 6, or sorry, value of y when x is equal to 8 and w is equal to 20. So we form the equation of variation. So that k we got, which is equal to 5, and the equation which is connecting this one was like w is equal to x squared k over y. But since now we know the k to be like w is equal to 5, the value of k, x squared over y. So this is our equation of variation. So coming back to our question, they say value of y. They want the value of y when x is 8 and w is equal to 20. Don't waste time making a subject of a formula to sort itself, so we substitute. What is w? W they said is 20. What is our x? They are saying 5 first of all, and then our x they are saying 8 squared. So over what is our y? Our y we don't know. It's the one we are solving. So from here we can simply do this. We can cross multiply. So this would be like 20y is equal to 5 times 8 times 8. Reason why I'm not saying 64, it's easier to solve when it's distributed like this, and like when you go and you're not using calculator. So here divide by 20 and everything here by 20. So when this cancels, we have y is equal to 5 here is 1, 5 into 20 we know it's 4, 4 here is 1, 4 there is 2, 2 times 8 is 16. Therefore your y is equal to 16, and your teacher will be happy and the examiner to give you a tick. That's how easy joint variation is. In our next video, we'll look at partial variation and some few examples, maybe to prove variation and also to do the graphs. Otherwise, wish you the best and keep it down. Team Dafloid, invite your friend.